Hello. In this work, my colleagues and I set out to explore how the location that is fixated modulates the neural response to upright and inverted faces in two groups of children and adults. Past research indicates that although there is evidence of adult-like specialized neural responses to faces from early in development, these processes continue to develop throughout childhood. The face inversion effect, in particular, is often considered a hallmark of specialized face processing, with enhanced or differential processing of upright faces compared to inverted. The classic ERP marker of the face inversion effect in adults is a larger and delayed N170 response to inverted faces, an effect that is not reliably present in children under 11 years of age. One model of the N170 suggests that it is generated from two neural processes, a simple eye detector alongside a neural inhibition process, whereby the response to individual facial features at fixation is minimized to support the holistic processing of the face. Now, behavioural evidence indicates that younger children preferably rely more upon information from the mouth area, in stark contrast to adults who have been robustly shown to rely on information from the eyes. In this project, we've been exploring how these developmental differences in preferential feature use might contribute to their distinct neural response to upright and inverted faces. This is a multi-experiment study where participants first complete a number of eye tracking tasks, followed by the EEG and behavioural tasks presented in the poster. We had three groups of participants in the study: adults, younger children, and older children. In the main task, the participants passively viewed faces presented in both upright and inverted orientations while they watched out for a small letter. Critically, faces were presented on screen at different vertical locations to systematically force participants to fixate the nasion, centre of the nose, or the mouth region. Our analysis focused on two important early visual evoked responses, P100 and the N170. For the N170 response, which is shown in the right panel, contrary to expectation, we did not see a three-way interaction of fixation, location, orientation, and age group. We did see an interaction of orientation and age group, with younger children not showing a face inversion effect, where older children and adults do. And we saw an interaction of orientation by fixation location, driven by a smaller face inversion effect when the mouth was fixated. However, we do report a significant three-way interaction on the P100. As you can see in the left panel, this interaction is largely driven by markedly different responses to upright and inverted faces in the adults and the younger children as a function of where they fixate. Future work will apply mass univariate testing to more fully characterize these differences and consider them alongside the eye tracking findings. Finally, in the poster, we also present a new behavioural face matching task. Although performance is close to ceiling in standard trials, when visual noise is added, there's a significant interaction between orientation and participant age group, such that only adults and older children show enhanced matching ability for upright faces. These results mirror the EEG findings for younger children who did not show a differentiated N170 for upright versus inverted faces. This work was supported by the Birkbeck Institutional Wellcome Support Fund and the Portuguese FCT. Please come to the poster to find out more.